Okay, so let's look at a few more examples. On our next one, we're doing cosine of pi twelfths. Okay, so we need to find two angles that add to pi twelfths or subtract to pi twelfths. If the pi twelfths is giving you a hard time, like sometimes it's hard to see, these ones we could change all to pi twelfths. So this pi 6 would be 2 pi twelfths, 3 pi twelfths, 4 pi twelfths, and so forth. So this would be 6 pi twelfths, and you could do that. If that's hard for you, change it to degrees. So let's say I wanted to change this degree. I take pi twelfths times it by 180 over pi, because 180 over pi is just 1. Pi's are going to cancel out. So 180 divided by 12, which is 15 degrees. Okay, so if you don't like the radians, change it to degrees. So if I look at that, cosine of 15 degrees is the same thing as, let's say, cosine, that's a cosine by the way, cosine of 45 minus 30. Or cosine of pi twelfths is cosine pi fourths minus pi 6. Again, there are other options. Sorry, there are other options, but I'm just going to give you one of the options. But if you come up with a different subtraction, then that is just fine. There's actually tons of them. But, you know, I'll just stick with this one. So I'd have cosine pi fourths, cosine pi 6, instead of a minus, which I have here, that's a minus by the way, I'm going to do a plus. Sine pi fourths sine pi 6. So square root 2 over 2 times square root 3 over 2 plus square root 2 over 2 times 1/2 square root 6 over 4 plus square root 2 over 4. So square root 6 plus square root 2 over 4. If you want, you could always check these. So if I put in cosine pi twelfths, I need to be radians. If I do cosine 15 degrees, okay, and whoops, so square root 6 plus square root, oh my goodness, plus square root 2 divided by 4, and we get the same thing. It's always nice sometimes to go back and actually check these. As I said, if you notice, if I left it 45 degrees and 30, I would still have got the same answer. So if you struggle with radians, change it to degrees. If you like radians and they are easy for you to find on here, use them. They're great, and it's good to know how to use those and be familiar with them. I just know if that's where you're getting stuck, is figuring out two numbers that either add or subtract to pi twelfths, because you're having a hard time doing all of your common denominators, and do it to degrees. It's just time saver. Okay, so I've got sine of 195. So I can know that sine of 195 is the same thing as sine of 45 plus 150, or sine of 240 minus 45, or any combination of things. So if you are, when you're going through these problems and you come up with two angles that either add or subtract to the given one, and it's different than what I would have done, no worries, it will work. Okay, you don't need to worry about those. One thing I want to quickly point out is if you look, cosine pi twelfths would be in quadrant 1, and cosine is positive. So check to make sure your answer is positive. Sine of 195 would be in quadrant 3, and sine is negative in quadrant 3. So when I do get my answer here, no matter what set of numbers I use, I should get a negative solution. Okay, so I'm going to grab this, see if I get everything. Okay, so I'm going to use sine. So I have sine of 45 cosine of 150 plus, and this is telling me it's going to be the same, so plus, and then I have cosine of 45 sine of 150. Okay, using my identity to write that out. Let's see, make sure I wrote it right. Sine, cosine, cosine, sine. What if I got my cosine and sine, like those two just moved? So it said sine 150, cosine 45. Would that matter? No, because this is multiplication. We just have to make sure we have sine 45, cosine 45. Cosine 150, sine 150. Okay, so sine of 45 is square root 2 over 2. Cosine of 150 is negative square root 3 over 2 plus cosine of 45 is square root 2 over 2. Sine of 150 is 1/2. So I have negative square root 6 over 4 plus square root 2 over 4. So negative square root 6 plus 2 over square root, over 4. Ew, that's ugly, sorry. So sine of 195 equals negative square root 6 plus square root 2 over 4. Okay, and just for my own curiosity, see, sine of 195, okay, it's negative. That's good because that was in quadrant 3. So then let's check my answer, make sure it's the same. Negative square root 6 plus square root 2 divided by 4. They're the same. I should be good on that. And my lights just went out. Okay. Let's do our next one. So we have sine of 19 pi twelfths. Again, if you notice, you could do pi twelfths. These are actually really nice with pi twelfths. So 2 pi thirds, okay, becomes 8 pi twelfths. You can do a quick conversion and then go ahead and leave it in radians. Again, if you're not comfortable with leaving them in radians, change it to degrees. Okay, so if we change that to degrees, I get 285 degrees. Okay, I tend to do things in degrees just because I can find combinations that add and subtract to 285 using my unit circle, maybe a little bit faster than 19 pi twelfths. We're more familiar with whole numbers versus fractions, but if you are confident in these, stick with them. It's always good to be very comfortable with those. Okay, so I could look at that and I could say that is sine of 330 minus 45. I could say that's sine of 135 plus 150, or any other combinations I might spot. Does it matter which one I use? No, it doesn't, as long as these two numbers either add or subtract to my 285. Okay, so looking at this, so I have sine, let's see, make sure I'm looking at my identity. So sine of alpha, so sine of 330 cosine 45. If this is minus in my formula, it is also minus. And then I have cosine of 330 sine of 45. Okay, so sine of 330 is negative 1/2. And then cosine of 45 square root 2 over 2 minus cosine of 330 is square root 3 over 2. And sine is square root 2 over 2. If you remember, x is cosine, y is sine. So real quick, we're in quadrant 4. all students take calculus, so cosine should be positive. We're dealing with sine, so my sine should be negative. Ooh, looks like my video is having issues. Hopefully this one turns out okay. So then I have negative square root 2 over 4 minus square root 6 over 4. So negative square root 2 minus square root 6 over 4. My answer is going to be negative. I can look at that and see that. If I check, I have sine of 285. Okay, and then if I check my answer, negative square root 2 minus square root 6 divided by 4, and they're the same. Okay, I'm going to end this video because, as I said, oh, just stop freaking out. I don't know what was going on. So there is my answer. Okay. Let's see, I have a couple examples of tangents, and then we're going to use our calculators. Oh wait, we're going to simplify these. We've got a few different things we're going to do. Sorry, there's quite a few videos today, but we'll be able to handle it. Okay, next video coming up.